Hello students, welcome back to this session, and in today's session we are going to cover a miscellaneous exercise. A small disclaimer: the images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Now, comes to this question. So here, the relation f is defined by this fx rule. Fx is equals to x square whenever x is greater than equals to 0 and less than equals to 3. Fx is 3x whenever x is greater than equals to 3 and less than equals to 10. We are having another function g, not function, a relation g. Gx defined as x square whenever x is greater than equals to 0 and less than equals to 2. And gx is equals to 3x whenever x is greater than equals to 2 and less than equals to 10. Then we have to show that the given f, this relation f is a function, but your g relation is not a function. Quite simple question, straightforward. We'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So quite simple. So just recall the definition for a function to be, a relation said to be a function. When we say that any relation is a function, quite simple, then first of all, the inputs, the set of all inputs must be same as the relation domain. Clear? And also we must have that every element from the domain has one and only one image. So using that, the f is a function and g not a function because, so solution, relation f is defined as fx is equals to x square when x is greater than equals to 0 and less than equals to 3, and fx is equals to 3x when x is greater than equals to 3 and less than equals to 10. So you can easily observe that what we are having for any x input, we are having the domain set as the same as the input set. Clear? And for every element in that domain, we are having exactly one and only one image. Clear? So this is my function. While, so therefore for every x in the domain, what we are having is a unique image. Thus f is a relation. Now for g defined in this manner that gx is x square whenever x is greater than equals to 0 and less than equals to 0, and gx is 3x whenever x is greater than equals to 2 and less than equals to 10. So you can easily observe that for input 2, we are having two different outputs, 4 and 6. So for this element 2, we are having two different images. So g not a function. Now this question, quite simple. if fx defined by x square, so for every input what we are having as our output x square, then just find out this expression f of 1.1 minus f of 1 divided by 1.1 minus 1. Quite simple problem. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So solution, fx defined by x square. So f of 1.1 is simply what? 1.1 whole square. Now f of 1 is 1 square and denominator remains the same. So 1.1 minus 1. Now this will be 1.21 minus 1 divided by 0.1. This gives me 0.21 divided by 0.1, which is 2.1. Clear? Very simple approach, very simple question. Moving to next. This question, quite interesting. So you have to find out the domain of the given function. A function is fx is equals to x square plus 2x plus 1 divided by x square minus 8x plus 12. If you recall, what type of function is this? Rational function. Why? Because numerator and denominator both are polynomial function. Yes? So just give me the domain. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we are given with a rational function. So domain is going to be all real numbers except 2 and 6. So domain can be any real number except 2 and 6. How? Solution. The given function is fx is equals to x square plus 2x plus 1 divided by x square minus 8x plus 12. Now, what I am going to do? Just observe that what real number values you cannot give to this expression. So first thing first, that the denominator, you do not want your denominator to be 0. Yes, denominator cannot be 0. So the first thing you have to check is for what value this expression becomes 0. Clear? So what you do is quite simple, that for this quadratic expression x square minus 8x plus 12, you try this expression to write in factor form. So the factor form for this is going to be x minus 6 times x minus 2. Now if you put 6 and 2, the denominator becomes 0, but you do not want your denominator to be 0. So what you are going to do is quite simple, that you just eliminate the 6 and 2 from the domain set. Now, are there any other values or any other condition which restrict ourselves onto other real numbers? Are we having any other real numbers which we cannot apply over here? No. Except 6 and 2, we can use any real number as our input. Yes? So set of all inputs will be what? all real number except 2 and 6. This question. Now in this we have to find both domain and the range set. So fx is equals to root of x minus 1. So find out the domain as well as the range. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So question quite simple. You are given with a function, real function fx is equals to root x minus 1. Real function meaning the domain and the range set both are from where? The reals, set of reals. Now, so the domain is going to be this set or any real number greater than equals to 1, and range set is going to be any real number greater than equals to 0. How? Just see a solution. So as given fx is equals to root of x minus 1, it can be seen that root x minus 1 is defined for what values? Inside root, the expression must be what? Always non-negative, meaning greater than equals to 0. Whenever you see root and then some expression, then the first thing you have to do is put that complete expression inside the root greater than equals to 0. Clear? Now, in this case, we are getting x minus 1 greater than equals to 0. Now just solve for x in order to get the some condition. So in this case, we are getting x must be greater than equals to 1. Yes? Are we having any other condition? No. So therefore, the domain of f is simply set of all real numbers greater than or equals to 1. In interval terms, we are going to write half closed open interval, closed at 1, open at infinity. Now for range set, how we are going to do? Quite simple. As we are having x must be greater than equals to 1, this means x minus 1 is greater than equals to 0. If you put root to both sides, you will get root of x minus 1 is greater than equals to 0. So from this approach, you can also get your range set, which is all real numbers greater than or equals to 0. You can also try the approach by just putting fx is equals to y. This question. So again, a function is given to you, mod of x minus 1. You have to find out its domain and range. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem, as we have already learned about this modulus function. Yes? So domain set is going to be the complete set of R, and range is simply inverse. If you are describing, it is a set of all non-negative real numbers. In terms of set, yes, the set in terms of intervals, the set is going to be half closed and open, closed at 0, open at infinity. So how we are getting our domain and range? So first of all, fx is mod of x minus 1. it is clear that mod x minus 1 is defined for all real numbers. You can use any real number here without any restriction. Yes? So domain is going to be the complete set of reals. Now, for range, you from the definition, if you recall, the mod x is always gives me the what value? Non-negative outputs, non-negative values. So in this case also, we are getting the range set as non-negative real numbers. Clear? This question. So we are having a function. So function defined in set builder form, collection of all pairs x comma x square by 1 plus x square such that x belongs to the set of reals. So this is your function already given to you from where to where? R to R. Now what you have to do is simply find its range, the range of this function defined here. Clear? You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple. Function already given to you. For each input, you are getting your output as x square by 1 plus x square. Yes? Just find out the range. So range is going to be this interval closed at 0, open at 1. How? So solution. So the rule is quite simple that for each input, you are having your output as x square by 1 plus x square. Yes? Quite simple. So we are using our approach where we replace fx by y. So y is equals to the output expression, which is x square by 1 plus x square. Now just cross multiply. You will get y plus x square y is equals to x square. Now just take this expression x square y to the right hand side. You will get your equation as y is equals to x square times 1 minus y. And from here you will get x square is equals to y by 1 minus y. And apply root to both sides, you will get x is equals to some expression of y, which is plus minus root y by 1 minus y. Clear? Now, as already given that each input, your domain set is simply your complete set R, meaning your x is from where? The set of reals. So, if this is from reals, okay, now as I have already told you, if you ever encounter with this root, under root thing, then what you have to do is, the first thing, put this expression greater than equals to 0. Yes? So, you established an inequality which is y divided by 1 minus y greater than equals to 0. Now, you have to solve for what values you can use for y in order to get your range set. So, what I did is just multiplied 1 minus y in numerator as well as in denominator y. Why I did? Quite simple, to make this denominator positive, some positive thing. Yes? So now in denominator I am having 1 minus y whole square, which is always gives me some positive thing. It can be 0, yes, but cannot be negative. I want non-negative thing here. Clear? Now what I will do is, I can easily solve for this inequality. How? I want this expression to be greater than equals to 0, and I know square of any real number is always non-negative, meaning I want the complete expression to be positive and denominator is already some non-negative, meaning the sign only depends on the numerator expression. If numerator is positive, then the whole expression is going to be positive. If numerator is negative, then the whole expression going to be negative. Now it is easier to solve for numerator by just simply multiplying or making the denominator as square of some expression. Clear? So I hope now it is clear why I multiplied 1 minus y to the numerator as well as to the denominator. Now just look for the conditions on y. So one is that denominator cannot be 0. So what I want, that y cannot be 1. So one condition must be y cannot be 1. Clear? Now in order to make this whole expression positive, I am just only focusing on to the this expression which is in the numerator. Why? Because denominator doesn't play any role here. So y must be 1 minus y greater than equals to 0 in order to get this whole expression positive, non-negative. Now what values for y this expression going to be greater than equals to 0? Quite simple. When y is greater than equals to 0 and less than equals to 1. Clear? So you are having now two conditions. One is that y must be greater than equals to 0 and less than equals to 1. And another one is that y cannot be 1. Which this condition is simply represented over here. Y is always less than 1. Why? Because the denominator could be 0, but we do not want our denominator to be 0, and we know square of any real number is always positive, and the square gives me the 0 output when input is 0. So in this case I do not want input to be 0. So what I am having is 1 minus y whole square is strictly greater than 0. This gives me y is less than 1. So you want your y values such that both condition must be satisfied. So you want your y values to be less than to be 1 and lying in this interval. So the possible values for y satisfying both conditions are y such that y is greater than equals to 0 and less than 1. So range set is simply the interval closed at 0, open at 1. This question. We are having two functions from R to R. First one defined as fx is equals to x plus 1. Second one defined as gx is equals to 2x minus 3. What you have to find out is the algebra of functions, which is the addition, the subtraction and the quotient. Clear? F plus g, f minus g and f divided by g. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, two functions fx and gx given to you. Just find out fx plus f plus g, f minus g and f by g. So f plus g is going to be 3x minus 2, f minus g is going to be minus x plus 4, and f by g is going to be x plus 1 by 2x minus 3, where x cannot be 3 by 2. How? Quite simple solution. So we are just going to use the definition how we define the algebra of functions, two real functions. So in case of f plus g, we are going to just add fx and gx each output in order to get the main f plus g function. So in this case, x plus g plus 2x minus g, which is 3x minus 2. So we are getting f plus g as 3x minus 2. Now for f minus g, so just simple calculation, fx minus gx, which gives me x plus 1 minus 2x minus 3. The outcome is simply minus x plus 4. So f minus gx function is simply minus x plus 4 or 4 minus x. Now for f by g, if you recall the definition, how you defined it? So fx by gx, where the gx cannot be 0 in its domain. Clear? So fx expression x plus 1, gx expression 2x minus 3, and we want that this denominator cannot be 0 or this gx cannot be 0. So we just look for the x value where we are getting the denominator 0, and we just are going to exempt that value from the domain. So 2x minus 3 is not equals to 0, which is x cannot be 3 by 2. So f by gx is simply x plus 1 by 2x minus 3, which gives me x not equals to 3 by 2. Clear? This question, f, this function f given in roster form. So you are having 4 ordered pairs, 1 comma 1, 2 comma 3, 0 comma minus 1 and minus 1 comma minus 3. This is your function. Now your fx is defined by ax plus b. Your fx defined by ax plus b for some integers a and b. What you have to do is find these values for a and b. Clear? Quite simple problem. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. As we are given with f a function and defined in this manner that fx is equals to, for each input x, the output is ax plus b. Then find out a and b. So a value is going to be 2 and b value is going to be minus 1. How? Solution. F already given to us in roster form, meaning for input 1 the output is 1, for input 2 the output is 3, for input 0 output is minus 1, and for input minus 1 the output is minus 3. So we are going to use this information. So the input output relation defined in this manner, that for each input x we are having output as ax plus b. Now for input 1 the output is 1. So using this information, just substitute x1. So you will get f of 1 as 1, as output is 1. So you will get your equation as a plus b is equals to 1. Clear? Now for input 0 we are having output as minus 1. Using the information, so for input 0 output is minus 1. So this gives me a times 0 plus b is equals to minus 1. So this gives me b value as minus 1. Now using the equation a plus b is equals to 1, so just substitute b value, which is minus 1, into this equation to get your a value. So a is going to be simply 2. Clear? So A is 2 and B is -1. This question, are your relation from n to n, set of natural to natural, described in this set builder form, that collection of all A comma B ordered pairs such that both AB belongs to set of naturals and A must be is equals to B square. Now what you have to answer is the given statements are true or not. Justify your answer in each case. Quite simple. So first statement says that A comma A, this ordered pair belongs to the set of belongs to this relation R for each natural number. Clear? Second says ordered pair A comma B belongs to R if this pair belongs to R, then B comma B comma A pair also belongs to the relation R. And third says if two pairs already in the set R, meaning A comma B and B comma C, then this pair, this ordered pair A comma C is also in the relation R. Quite simple problem. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem, as you have to just check. So all the three statements provided to you are false or not true. How? So solution. So as are described by collection of all ordered pairs A comma B, both A comma B from set of naturals, and A is equals to B square. In first, you are given that this pair A comma A always in the relation R for every natural numbers. So we know when a pair belongs to the set of relation of this relation, when you have this condition satisfied. Yes, but if you observe 2 comma 2 does not belongs to the relation R. Why? Because 2 is not equals to 2 square. So it is not in general true. Now for second, if any pair A comma B is in the relation R, so we are taking pair 9 comma 3 which is in the R, yes, as 9 is equals to 3 square. So this condition satisfied. But if you observe, are we having 3 comma 9 in this relation R? Are we having? So no. Why? Because if 3 comma B belongs to R, then 3 must be equals to 9 square, but it is not equal. So 3 comma 9 doesn't belongs to the relation R. Therefore the second statement is also not true. And for third, so here if you have two such pairs, so 16 comma 4, so we are taking one 16 comma 4, another one is 4 comma 2, as we are having the second element of this pair same as the first element of this pair. So is the case here. Now are we having 16 comma C belongs to R? No. Why? In order to this pair belongs to R, what we want is simply 16 must be equals to 2 square, but this is not equal. So again we are getting false, or this statement is also not true. This question, A set with 4 elements 1, 2, 3, 4, B set with 6 elements 1, 5, 9, 11, 15, 16, and you are given with that your F relation with 5 ordered pairs 1, 5, 2, 9, 3, 1, 4, 5 and 2, 11, and you are provided with 2 statements. You have to answer that the statement is false or true. Just provide your answer in each case, your justification. Clear? So first says that the given F is a relation from A to B, and second says that F is a function from A to B. So you will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem. A, B sets given to you. F relation. So we have to find out that it indeed a relation or not, first of all, and then find out is the given relation or whatever this is a function or not. So first is true, meaning this is your relation, while the second is not true, meaning your F is not a function. Why? Solution. So as we are given with A and B two sets, and A cross B will be your set of all ordered pairs, in which you will have how many ordered pairs? So 4 times 6, so 24 ordered pairs in the A cross B Cartesian product. Clear? Now, in order to be a relation, you must have the subset of this A cross B. So if F is your relation, then F must be a subset of A cross B. So what we are given with is F in roster form. So first, a relation from a non-empty set A to non-empty set B is a subset of the Cartesian product A cross B. So in this case, F is a subset of A cross B. Why we are saying F is a subset? As F, when do we say that any set is a subset of the other? When the element of this set, in this case F, every element from this set must be in this set. Yes? So we are having 1, 5 here, 2, 9 here, 3, 1, 4, 5 and 2, 11. So we are having all the elements which belongs to the relation, which belongs to this set F already in the set A cross B. So by definition, F is your subset of the set A cross B. So a relation. Now for second, just observe that this element 2 from the domain set having 2 different images. So this is not a function. Why? Because in function you want that every element from the domain set must have one and only one image. Clear? Now this question, F, which is your subset of Z cross Z, meaning Cartesian product of a set of integers to set of integers, defined by collection of all ordered pair AB, comma A plus B, where AB both belongs to the set of integers. Is the given set a function from Z to Z? You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem. So, not a function. Why? Solution. If you observe how we define this set, that the first element of this ordered pair is AB and second element is sum A plus B. Both AB belongs to the set of integers. Now, in order to be a function, or we know that a relation from set A to B is said to be a function, that every element of set A has unique image in set B. If you observe here, just pick some integers, say 2, 6, minus 2, minus 6. Now, 2 times 6, 2 plus 6 is some ordered pair in the set F. Yes? Minus 2 times minus 6 and minus 2 plus minus 6 is another ordered pair in the set F. What you are observing is, this gives me ordered pair 12, 8 and this gives me 12, minus 8. Both belongs to the set F. Now, it can be easily seen what, that for this element 12, we are having two different images, 8 and minus 8. So, F is not a function. Clear? Now this question. Set A given to you, 9, 10, 11, 12, 13. F from A to N defined by this rule that for each N, N is coming from where? From this set A. Okay, N is coming from the set A. So from each N, the output is simply the highest prime factor of the number N. So using this rule, you have to find out the range of the set F. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Here we are given with set A and a rule F, in this case a relation from A to N. We do not know that this is a function or not for now. What we want is simply that this is a relation. Yes, this is a relation and we know that we can easily find out the range of any relation. Clear? So, defined by Fn is equals to the highest prime factor of the number n. N coming from the set A. Clear? Now find the range. Range is quite simple, just the output, collection of all outputs. So 3, 5, 11, 13. So solution. So set A already given to us 9, 10, 11, 12, 13 and F from A to N defined. So for each input from the set A, the output is the highest prime factor of N. So for 9, the highest prime factor of 9 is 3. For 10, the simply prime factors are 2 and 5 and the highest is 5. For 11, the highest is the number itself. And for 12, two factors 2 and 3 and the highest is 3. For 13, the highest is the number itself. Now F of 9, simply output is the highest prime factor which is 3. For F of 10, 5. For f of 11, the output is 11. And for f of 12, 3. F of 13, 30. So, the range of f is the set of all outputs when n belongs to the input set. So, the range set is simply with 4 elements 3, 5, 11, 13. Clear? Anybody having any doubt? Please ask. Anybody? Okay, I am assuming that everything is clear. And also the time is up. So we have to end our session here. So thank you all. And please do